Alright, hello everyone, and welcome to the AI Research Roundup. I am Alex, your host. Today is May 7th, 2025. We are looking at a research paper from Hugging Face's trending list, published about 8 days ago. This paper, TF1EN3M, 3 million synthetic moral fables for training small, open language models, introduces a vast dataset. It has 3 million English fables created using a structured storytelling template by instruction-tuned language models, AIs trained to follow specific directions. The goal is to advance natural language processing, or NLP, teaching computers to understand language and values. So, how did they actually create these millions of fables? Well, the figure on page 4 shows their full pipeline. It begins with core story elements, like character, trait, and setting, feeding into a structured prompt template. Candidate AI models then use this template to generate sample fables. These generated fables are then carefully checked. An LLM-based evaluator, essentially another AI judge, scores them on grammar and creativity. They also use metrics like self-BLEU, which measures how repetitive the fables are, distinct N for word variety, and flesh reading ease for readability, before selecting the best model. Okay, so after that evaluation process, this table on page 7 shows the results of the LLM-based evaluation. It compares 10 candidate AI models, all relatively small, scoring them on grammar, creativity, moral clarity, and adherence. That is, how well they followed the story template. We also see data on tokens, the basic units of text for these models, and latency, which is how quickly they produced a fable. ALLAMA 3.1 instruct model, for instance, performed strongly here, particularly on grammar and adherence, making it a top pick for generating these fables. Alright, so complementing the AI judge's evaluation, this table presents other important text quality metrics. These are automatic checks, not relying on another language model. We see self-BLEU, where a lower score indicates greater diversity in the fables, meaning they are less repetitive. Then, distinct -1, a higher score here shows a richer vocabulary, and flesh reading ease, where higher scores mean the text is easier to read. For instance, the QN 2.5 model here shows excellent readability. These metrics helped confirm that the overall generation process, using the selected model, produced diverse and accessible stories. Building on those text quality checks, this next table on page 8 delves into the age appropriateness of the fables. It shows the distribution of generated fables across different age groups, let's call them A, B, C, D, and E, as estimated by an LLM-based classification, essentially another AI judging suitability. The MetaLlama/Llama 3.1 to 8B instruct model, which we saw performed well, has a striking 92% of its fables in age B. This is important because the goal was fables for 4 to 7-year-olds, and age B appears to be that target category, confirming the model's output is well suited. So these fables are well suited for young kids. The big takeaways? First, we now have TF1EN3M, a massive open dataset of 3 million moral fables. This is a new corpus, or large text collection, for researchers. Second, this work shows that even smaller, open language models, those with about 8 billion parameters, their internal learned settings, can efficiently create high-quality moral stories. This is a boost for value alignment, which is about teaching AI to act by human principles. That is our AI Research Roundup for today. Thanks for tuning in.